welcome everyone. This is Nishant from IIT Calicut, and today we are solving Sameer Bansal Book definite integration portion. Okay, and this is single correct option questions. That question is fluttering on their screen. Okay, and I am request all of you to solve first of all by yourself, because then only you will get benefits. Okay, and let's try to solve this question. Okay, here we can see clearly that we have to solve numerator and denominator first of all separately. By intuition we can say, let's solve it. So I have written I and R, which means integration of numerator separately. So do integration first, and here e raised to the power sin x first of all must be multiplied with each of these two terms, because then only we can get something. So multiplied x cos x into e raised to the power sin x dx plus integral from 0 to pi by 2 e raised to the power sin x dx. Okay, and now in this portion we can see clearly by parts is applying. Okay, applicable, by parts is applicable because this function can be integrable easily. So let's assume it v, and this is differentiable, so let's assume it u, and this function you can leave it as it is, because in final we can see what will happen to this. Okay, so apply by parts in this question, and for the sake of time let's forget about the limits, because it will create problem. In final term after solving by parts we can apply limit. Okay, so do apply the formula of by parts here. So you leave it to u and do integration of b cos x dx e raised to the power sin x dx minus differentiation of u, and then do integration of v cos x e raised to the power sin x dx, and one more dx for this integration. Okay, and let it leave it as it is. Now you can solve this integration by substitution. Let's suppose let's substitute t equals sin x and do substitution. It is very simple kind of integration, cos x dx. Let's substitute it, then we get what, e raised to power t dt, simply e raised to power t, and here t means sin x, e raised to the power sin x. Okay, this integration clearly equals to this, so let's put it x e raised to the power sin x. Okay, and in this also differentiation of x with respect to x will become 1, and this integration we have solved here, e raised to the power sin x dx, this has ended, and leave it as it is, 0 to pi by 2 e raised to the power sin x dx. Okay, and now this is the final term of this by parts. So now we can apply the limits. Let's apply the limit 0 to pi by 2, and this whole term is on which limit is applied. Okay, this means whole term. Okay, and clearly visible, this and this is gonna cancel out each other, and on application of limit it will become what, pi by 2 e raised to power sin 90 will become 1, and when minus 0 is applied it will become 0, so it will become what, pi by 2 times c. This is first, this is our integration of numerator portion, and then follow the same procedure for the denominator also. You will get integration of denominator as minus of pi by 2. Okay, I am not doing this because the video will become so long. It's exactly identical. Okay, you can do on self. Now since we have to find integration numerator upon integration of denominator, and since absolute value is asked, so put a mod. Okay, and apply the pi by 2 times c upon minus of pi by 2. This will become what, modulus of minus c, which means e. So our correct option is A. So if you like the video, do subscribe, like, and hit the bell icon. Okay, and wait for the next video. Okay, thank you, bye bye.